All right, so here's some hints on solving problem number 5. You've got a uniform plank. It is being pulled on by 3 ropes. Tension 1 heads off to the right at an angle. Tension 2 goes straight up, and tension 3 goes to the left. And there's a weight hanging somewhere from the left end, and that's given to you as W. So be careful. Don't multiply that by G. If it's a weight, it means it's already been multiplied by G. It's measured in newtons. The plank itself has a mass m, and so the force acting on that is m times g. So these are the forces that act on the rigid object, which is our plank here. And we have to find the tension T1. Since we don't know T2 and T3, it is easiest to make this point right here our first pivot, P. And with that as our pivot, we can apply the Newton's second law for rotation, which is the sum of all the torques about P must add up to 0. And so we can find the torques. So if you imagine this rigid object being pivoted on this left end, the tension T1 is trying to rotate it in the positive direction, so that's a positive torque. So the positive torque is going to be T1 times the distance from the pivot that it acts, which is L, that's from here to here, times the sine of the angle between the direction of the force. So the direction of the force is that way, and the radius is this way. So you can use theta, or you could calculate this angle here, which is 180 minus theta, but the sine of either of those angles is the same, so it doesn't really matter which one you use. So I'm just going to use sine of theta. So this is the positive torque. The negative torque is caused by this force, which is W, remember, no G, times the distance it acts from the pivot, which is given to you in the problem. I'm just going to call that X, but that's given in the problem, how far this is from the left end. And there is a torque created by the weight of the bar itself, so that's the force applied, mg, times the distance it acts, which is the length of the beam divided by 2. It's a uniform beam, so the weight of the beam acts in the center. And all of those torques add up to 0, and so T1 and T2 and T3 don't factor into this equation, and you can fairly easily solve for T1. Okay, so that's part A. Part B, you got to find the tension T2. Probably the easiest way to do that is to think about the sum of the forces in the y direction. They have to add up to 0, so the forces going up, which is T2, plus a component of T1, so that's T1 times the sine of theta, that's the component of T1 going upwards, minus W minus mg equals 0. Now remember, these are forces, not torques, so we're not multiplying them by the distance from the pivot. We're just taking the force in the upward direction, T2 and T1 sine theta, minus the forces going down, and that equals 0. Since you found T1 in part A already, you can solve this for T2. So you can solve for T2 there. And then lastly, to find part C, if you want to find this tension T3, you can just simply add up the forces in the x direction, because they also have to be 0. And so that tells you the forces going to the right, which is T1 cosine theta, minus the force going to the left, which is T3. Those are the only horizontal forces. They have to add up to 0. And since you've already found T1, you can, oops, you couldn't see what I was doing there. Add up the forces in the x direction, they have to equal 0. So the force going to the right, which is T1 cosine theta, the component of this force going to the right, minus the force to the left, which is T3, those have got to add up to 0, and so you can solve this for T3 because you already know T1. Okay, so that's the strategy for solving number 5.